Good morning, boys and girls, friends and neighbors, ladies and gentlemen. Today we're going to talk about multiplying and dividing, multiplying and dividing rational algebraic expressions. We're going to start this topic off by doing some review of multiplying fractions or just rational numbers, which is another word for fractions. We have been telling you all year long, when you multiply two fractions, you factor and cancel. Factor, then cancel. You factor the top and bottom, and then you cancel like factors. Most of you have been wanting to multiply the top, multiply the bottom, and then reduce. No, 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 no. You want to factor, then you're going to cancel. So I'm going to do a review of some rational numbers before we get into rational algebraic expressions. And some of these problems down the road are going to get kind of tricky. They're going to look intimidating. You just got to take a deep breath and know that you can do it. So let's start off with this guy right here. Let's start off with this dude right here. 49 over 24 times 36, 14. I could multiply 49 times 36 and 20, but who's going to do that? Not me. What I'm going to do is do some factoring and some canceling. So 49 is a nice one to cancel. 49 is simply 7 times 7. Now this guy's gone. I'm going to factor 24. 24 is going to factor 2 times 12, and you're going to see why I do this. And then 36 is going to be 3 times 12. Haven't done anything but some factorization thus far. And then 14 is going to be 2 times 7. Now we're ready to cancel. We have everything factored. We're going to cancel. Cross some stuff off. So let's see here. Ooh. There's a 7 here. Those are gone. This is kind of getting messy, but you have to be very careful. There is no other 7s on the bottom. Do I have a 3? I do not have a 3 on the bottom. I have a 12 here. Oh. Those 12s cancel. So all the cancellations, they become 1. So what do I have left? On the top, I have 1 times 7 times 3. And I keep in mind, 7 and 3 are prime, and 2 times 2 are 2. Both of the 2's are prime, so there's going to be no more cancelization that's going to happen. So 7 times 3 is 21. 2 times 2 is 4. And that is the product of these two fractions. And I know confidently that this is in reduced form because I factored and canceled all alike factors. You'll see this is a review. This is a 5th grade or a 4th grade standard review. Now we're going to go down here and we're going to divide two fractions. Here we go. We're going to divide two fractions. Let me extend the page here a little bit. And the first thing you do when you see the division symbol right here, the first thing you're going to do is turn that into multiplication. I'm going to use a dot for a multiplication. And I'm going to flip this fraction here, 54 over 35. Now I'm back to the previous example. I'm going to factor and cancel. And I see right away that 54 is a factor of 9, is a multiple of 9. 54 has a factor of 9, and it is. It's 6 times 9. 35, I can see that easily, is 5 times 7. And so now I'm going to cancel like factors. What do I have? I have these two 9s that are going to cancel. And I have these two 7s. And I know 6 has no factors that 5 has. So what do I have left on top? I have 1 times 6 times 1, 6. Do I have left on bottom? 1 times 5 times 1 is simply 5. So 7/9 divided by 35/54 is equal to 6/5. Easy peasy, lemon squeezy. Oh yeah. All righty. Let's go to the next page and let's do some good stuff. Some algebra stuff. Here we go. Oh, looks. Can't believe that I started on this difficult of a problem. Let's see here. Trying to find. Here we go. We're going to start on this page right here. This is the page that we want to start on right here. So this is a simple one. I have a multiplication. Oh, what I need to realize is that this guy is over 1. And now I'm going to cancel like factors. Let's see here. Oh, 7, 14, true or false, is 2 times 7. I have an X here, and I have a P7. Now, since I have the numbers, look what I'm going to do. I'm going to cancel this 7 right there. He's gone. He's gone. So as far as the numbers, what numbers do I have left? I have a 5 left on top. I have no other numbers. And left on bottom, I have a 2. And let's look at these X's. Here, left on top, I have an X times an X cubed. We've done a lot of these problems before. And I have a P on top. And then on the bottom, I still have an X squared. And I have a P to the 7th. Now, we've been doing this for weeks. So what do we have here? Just to write out a step, it's really not necessary, but I'm going to do it just to help you out here. This is going to be X to the 4th, P over 2X squared, P to the 7th. What is this going to do? Now I'm going to use the law of exponents. I still have this 5 here. It's going to be X to the 4 minus 2, P to the 1 minus 7, all over 2. And what do I have here? This is going to be 5. This is going to be X. Got the 7 there. X squared. P to the negative 6. I'm going to bring that P to the negative 6 down here, making P to the 6. So let's write that a little bit better. This is going to be 5 X squared over 2P to the 6th. The first type of problem, and keep in mind, this whole video is to help you with the next IXL standard that's about multiplying and dividing rational expressions. So they start off pretty easy, or they start off with review type problems. Now let's get to something that we haven't looked at a lot. Here is one here. This guy right here. You can only cancel like factors. You cannot cancel add-ins. So the 3's don't cancel, the X don't cancel, but you have to look at this guy right here as a complete factor. So they're gone. They are absolutely gone. What you can do is well, first of all, let's see if this guy right here factors. Let's come over here and see if this top thing here factors. I think it does. And the way these things work out, they work out pretty nice. Let's see, minus 10. Let's see here. 2 things multiplied together to negative 10 to add up to 3. 2 things multiplied together, negative 10. You really have to get your factorization skills down. This whole exercise will help that. Let's see here. Oh, let's see. Oh, yeah. I got it. It's going to be X plus 5, X minus 2. 5 times negative 2 is negative 10. 5 plus negative 2 is 3. So that's what this guy right here is. So look what I'm going to do here. I'm going to rewrite this top fraction here. And we're going to write it as X plus 5, X minus 2, over X plus 3, times X plus 3, over X plus 5. Now I'm looking for like factors, and I see them. Do I have an X plus 5? This thing cancels with this guy. And this guy cancels with this guy. And what do I have left? All I have left is this X minus 2 over 1. I don't have to write the 1. So all the factors on the bottom, this factor and this factor canceled. This factor and this factor canceled. These guys cancel. All right, let's go on to the next problem here. Let's see here. Let's see to investigate these different problems. Let's go up here. We're going to go, yeah, I think I'm going to go with this example here because it's another timesy. So let's do this example. Oh, let's see. Oh, boy, I got a lot going on here. The first thing, this is going to be easy to factor here. This is going to be easy to factor here. What I need to do is factor this rascal up here. I'm going to factor this guy. And this is going to take a little work. That's one of the reasons why algebra students don't like this, because it takes so much work. You just can't look at it and get the answer immediately. So let's factor this, and there's multiple problems within this one problem. Okay, so I'm going to use the AC method here. A times C is going to be, and we know what A is. A is equal to 3, B is equal to 11, and C is equal to -4, and I take A times C is going to be -12, and I want two numbers, P times Q to equal -12, and P plus Q, I want it to equal 11. And right away I see my numbers, because if I multiply 12 and -1, 12 times -1, I do indeed get -12, and if I add 12 plus -1, I do indeed get 11. So this will be a good review of factoring trinomials. So now I have my P and the Q, so I'm going to take this guy right here. I'm going to write this as 3x squared, and I'm going to go plus 12x minus x minus 4. And you know what to do now. I'm going to group these things in factor. I'm going to group those guys and factor out a common term from each of these two binomials. Factor out a 3x here. That's the common factor. Do not do it in yellow. I have a 3x here. It's going to be x, what, plus 4. And keep in mind, if we do this, this other binomial is going to have a factor of x plus 4. And I see, oh, what is it? It's going to be -1, because -1 times x is -x. -1 times 4 is -4. I have two terms. I factor the x plus 4 out, and I get 3x minus 1 times x plus 4. Now, there's multiple ways to get to here. But this is the way, the AC method. So this is going to be, we're going to see this AC method come up in multiple examples here. So now I'm back to this problem. And what I'm going to do, these binomials are going to be easy to factor. And so I'm going to rewrite this problem in factored form. And I note that the top thing, this numerator of the first fraction, doesn't have factor. The bottom is going to be 3x minus 1 times x plus 4 times, I have 3x minus 1. There's nothing that factors out of that. There is, if I look at this, a 10 comes out of that rascal. This is going to be x, well, let's see here, 2x plus 7. 10 times 2x is 20x. So just a 10 comes out of that. Hey, slow your roll here, buddy. Okay, so let's made a little mistake here. I think I was wanting that to be factor out of 10, and what do I have? I have x plus 7. And so now I'm going to cancel all the like factors. Oh, it would have been nice if that came out of 2, but it didn't. So what are my like factors? My like factors here, I have this factor, and I have this factor. They cancel. And right here, this is 2 times 5. But still, it doesn't factor because I have no individual factors here. This whole thing is a factor. I have no factor of 2 or 5 on the top. So what do I have left? So let's see here. This guy factors. And that's it. That's all that factors. And I'm just going to rewrite that. And the answer to this bad boy is going to be 2x plus 7 over bunch of stuff on the bottom. I'm going to write the number out in front. 10 times x plus 4 times x plus 7. And that's done. This is simplified. I can't do any more factoring. I cannot do any more factoring. Okay? Keep in mind, if you need to, I'm going to try to limit this video to about 20 minutes. So if you need to pause the video or rewind, have at it. So now let's do some division. And I think I had some divisions up here. Ooh. Well, we knew from the beginning slide, did we not? From the very beginning slide down here, if you're going to divide, what you're going to do, you're going to multiply and then flip the fraction. Look at you're going to multiply by the reciprocal. So let's go right here. And so this, this is going to be, this problem is going to become x squared minus 4x minus 21 over x plus 2. The division becomes times. This goes 1 over x minus 7. And now I'm back to a problem that I started off with, and I have to try to factor this top. Let's see here, because this is factored, and this is factored. Those are prime. So let's see if this guy factors. Is there two numbers that multiply together to equal negative 21, where those two numbers add up to negative 4? Let's see here. Negative 7 and 3. Yeah, negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. So this guy automatically, I don't need to use the AC, which I just did, but it's going to go x minus 7, x plus 3. That's what this guy becomes. I still have an x plus 2 here. And I'm times 1 over x minus 7. And now I'm going to cancel like factors. Oh, and I have this guy, and they cancel. And what do I have left? What I have left is simply x plus 3 over x plus 2. These problems are going to get very messy because you're factoring and cancels. You're going to have to be very careful when you do these IXL problems. I would strongly suggest when you do these IXL problems to have a paper and pencil and be ready to do some good factorization. Oh, let's see. We're going to do one more example here. And the first thing we're going to do is we're going to turn this into a multiplication problem here. This thing is going to be hard to factor, maybe. I have this guy right here, which is prime. And I'm going to times that 1 over x minus 5. Okay, so I need to do, what do I need to do? I need to factor this guy right here. Let's go over here and factor this guy. See if we can get this accomplished. I think we can. All right, so let's do the AC method. A times C is going to be negative 30 here. And I want two numbers, P times Q, to equal negative 30. And P plus Q to equal negative 13. Let's see here. I have negative 10 and 3. I have 5 and 6. Let's see here. Okay, we found them. And what are they? It's going to be negative 15, negative 15, and 2. Negative 15 times 2 is negative 30. Negative 15 plus 2 is negative 13. So this guy here then is going to be, if I'm going to finish the factorization of this rascal, it's going to be negative 3x squared minus 15x plus 2x minus 10. Now I'm going to do the factor by grouping again, getting a little bit over 20 minutes here, so I'm getting a little uncomfortable. Factor out the greatest common factor, which is 3x. I have x minus 5, And so this is going to be an x minus 5 over here, factorization, and looks like it's going to be times a positive 2. So I'm going to come over here, and I'm going to write this rascal here as 3x plus 2 times x minus 5 over 4x plus 3 times 1 over x minus 5. And now I'm going to cancel some stuff here. I'm going to cancel this. And what do I have left? I have 3x plus 2 over 4x plus 3. All right, good day. If you have any questions, just call me or text me, email me, and I will help you out.